Today I'm going to show you how to convert your SX3 mill from manual control over to PC control using an Arduino, or even if you want to add an additional control panel. Now, after you have removed your control panel from the head and you remove the circuit board from the bracket, you then end up with the control panel. Buttons that are familiar with you. Now, it's quite a simple and cheap procedure. All you have to do is solder some pins onto the one side of the press button. You can check it with a multimeter meter that when it's just sitting there, it's closed. When the button's pressed, it's open. So I've used the two pins, soldered them onto the two terminals. Then I have used, from the radio control section, the servo leads, which is a DuPont 3-way lead. I then removed the centre wire, just with a little blade, lift up the little tab there, slide it out. So then I've had multiple colours, so I've got red, black and white. So I like to colour code all my wires. So two reds, red and white, red and black, white and white. So that's a red series. On this side it's black and black, black and white, black and red. On opposite sides to the other one. So once you've soldered the two pins on, I use a bit of circuit board with the holes drilled in, two plates, and then that aligns it so as I can solder it in the correct position. Then you just add your connector to where you soldered the pins in. I've colour coded them. Then you buy a relay board. You can use one with a relay or the solid state relays. I swapped over and got a solid state relay. So this is an 8 one, and there is 1, 2, 3, 4, 5, 6, 7 connectors, and I have got an additional one that I'm going to hook up to the cooler. You may not want tapping, you may not want reverse, so it depends on what you want to use. Then add the wires in, and you can have, if you want to keep the original one in the head, you then have to run the wires somewhere and the control wires from the Arduino to it. So I'm removing the main plug that comes in from the head of the circuit board to here, from the main motherboard. And I'm running that through underneath the machine and up on a pendant. So this will be on a pendant, and the machine will be over there, and I'll be able to operate it manually out the front or through Mach 3, driving the Arduino. I then can program it to start, stop, forward, back, reverse, increase and decrease the speed. I've got an Arduino Mega board here. Any ones with enough connections will do. So the situation is I make up a holder to hold the board. I then, behind that container, I then have that board, the relay board, and you can either run all your cabling from where you have the Arduino board, or you add that in as well. So basically, move your circuit board, solder the pins to match your DuPont 3-way connector. Then they go to your relays. Get your Arduino, you select which pins you want to run. Now I have this bit of ribbon cable, so I will then just splice it, and they will run there. So basically from the Arduino to the input terminal triggers the relays, which then triggers a button push. So keep the original buttons. You then can run additional switches if you want another panel somewhere. Very cheap, very efficient. If you use Mach 3, you then can program it. If you've seen my other videos with the spindle sensor, the idea is that as the spindle sensor comes, it senses the position. You'll then send a feed to the Arduino. The Arduino will stop the spindle. Now with tapping, it is an instant reduction in speed. So what I will do is trigger it to switch it to tapping, then to stop. Then I will measure how many degrees out it is. Then I will then trigger that once it gets the signal, tapping, and work out how many seconds or milliseconds it will take to go around to the position I want, and then hit stop. 20 to 30 bucks. They're probably even cheaper now. The relay boards with mechanical relays are cheaper. These are 20 bucks, so say for 40 bucks you can have complete computer control. Well worth it. I have removed the cable from here, and it will go under a 600mm table and up, and that will give me enough to have the control panel outside the coolant cabinet to be able to access it. Hope you found this interesting, and another CNC4A idea to improve your machine and save you money. Thanks for watching.